When it comes to weather-related hazards, tornadoes and hurricanes get a lot of attention, and rightly so. And I think increasingly the same is true for lightning and heat. But one weather hazard still doesn't get nearly the respect it deserves, at least in my opinion, and it can make news just about any time of year. Let's take a look at a breakdown of weather-related fatalities by hazard. 5 are shown here. The blue bar is the annual average over the last 10 years. The maroon bar is just for 1 year, 2016. Lightning fatalities have come down in recent years. The average is about 30 per year. There have been very few landfalling tropical systems in the last decade, so hurricane fatalities are way down too. Now, the tornado and heat 10-year averages are still around 100 per year. Take a look at the flooding, though. The 10-year average is 91, which is actually slightly above the longer-term 30-year average. And in 2016, there were 126 fatalities, suggesting this problem is not improving. And when you break down recent flood fatality numbers by situation, you find that more than half occur in vehicles, usually people trying to cross flooded roads, a situation that's still way too common. And let's look at that situation a little closer. Here's a simple but realistic way to think about a vehicle in water. Now, a car's weight creates friction with the ground at the tires, which basically holds the car in place. And when water enters the picture, the surface becomes slippery, which reduces the friction. And water, of course, also introduces buoyancy that acts upward on the vehicle. The Greek jack of all trades, Archimedes, first told us about that buoyancy force and that it equals the weight of the fluid displaced by the object. Water weighs about 62 pounds per cubic foot, and cars take up a lot of space. And once some of the vehicle is submerged, the weight of the car is essentially reduced by the weight of the water it displaces. And as an example, let's assume say a 3,000-pound car. That would be typical. And say water rises just 6 inches up the body of the car. A typical car is maybe 5.5 feet wide and 14 feet long. We'll do the math for you. That's enough volume of car to displace 2,400 pounds of water. So that car's net weight essentially drops to 600 pounds. And that doesn't even take into account water displaced by the tires. Now, if the water is moving, there's a sideways force on the car that is proportional to the speed of the water squared. So if you double the speed, that force increases by a factor of 4. And when that sideways force exceeds the net weight of the vehicle, the car floats away. And keep in mind, we didn't consider here the fact that water reduces friction, which makes the net weight even less. No wonder the National Weather Service aggressively warns not to underestimate the power of moving water. 6 inches can knock over an adult. 12 inches of fast-moving water can carry away a small car, while 18 to 24 inches can carry away most SUVs and even vans. Indeed, in my opinion, the National Weather Service's slogan, "Turn around, don't drown," can't be repeated enough. Stay tuned. The extended forecast is next.